Okay. Hi, everybody. Thank you for joining us. This is Erin Nelson-Parek. I'm Associate Editor of Pipeline and Gas Journal, and we have a lot of information to get through, but before we start, I wanted to give you just a few notes. First, regarding the slides, you will receive a link to the slides and a recorded version of this webinar in your email a few days after the event. So you don't need to worry about that. You don't need to worry about taking notes or anything unless you have a few things you might need immediately. If you would like to ask questions, we would love to answer them. There is a Q&A panel available via the tab at the top of your screen. Just pick the one that says Q&A, and it's pretty self-explanatory. I'm sure you'll work it out from there. That'll let you ask questions all through the presentation, and then we'll get through as many as possible at the end of the session. If you have any problems, you can always shoot a question or email to me, and I'll help as best I can. And if not, you can always get the recorded version later. That's housekeeping. Let's move along to what we're tuned in to hear. Today's webinar, Improving SCADA Acquisition with a New Distributed Communications Architecture, is presented by Kepware Technologies, and your speaker is Steve Sponseller, Product Manager for Oil and Gas Solutions. I will turn it over to him now. Steve?
Thank you so much, Erin, and hello, everyone on the call, on the webinar. Thanks so much for taking the time to attend this with us. As Erin said, I'm a product manager at Kepware, and I'm focused solely on the oil and gas industry. And I'm going to spend the next, probably 30 minutes digging into the key elements from this paper that was co-written by partner Russell Treat of EnerSys. There will be a few polling questions peppered in this presentation, and we look forward to getting your answers. But first, give me a few minutes to give you some background information on Kepware. In fact, what better time than to start with our first poll question. So out of curiosity, on a scale of 1 to 5, those people on the call with us today, how familiar are you with Kepware? So 5 being very familiar with the company solutions, and then 1 being, not familiar at all. So we're always guess who, and Erin is actually running the poll questions, and you should have something up there you can answer in front of you, and I'll just give you a couple more seconds to answer that. Again, we appreciate your participation in this. Okay, so moving on. Who is Kepware Technology? So, for those of you that answered not that familiar, hopefully this will be somewhat enlightening. We develop software-based communication solutions used to meet the monitoring and control requirements of automation systems used in the discrete, batch, and process environments. Our software running in a variety of locations, ranging from automotive plants, food and beverage companies, packaging environments, pharmaceutical companies, building automation, power generation and distribution, and lastly, oil and gas. Very interesting, all the different industries that we touch with. Kepware has built its expertise over the years on understanding device-level protocols and also the various industrial application programming interfaces and lastly data models. All of these are necessary to move information between any component that you might find in your industrial control system. Our solutions are used worldwide and reach the end user either with our direct sales efforts, through relationships with distributors and system integrators, and lastly, as OEM versions to vendors who repackage our software into their own off-the-shelf solutions. And where we are located, so aside from one associate in China and in Switzerland that manage our international channels, our entire team is located here in Portland, Maine. This is to develop, market, sell, support this global customer base. And if you're interested in learning more about Kepware following this webinar, please do follow up with us. We'd love to get in touch with you. Okay. So, as far as what our solution is, we view our communications platform as the heart of your industrial control system, moving it from point A to point B. Our array of device communication drivers and application interfaces are especially beneficial when you have a diversity of hardware as well as applications that need data and a diversity that type of stuff these days. Sorry, I advanced the slide here. So data from devices is no longer needed just at the plant level. And in this graphic here, we're looking at the plant level there as the first level. And really, it doesn't even stop at the plant level, where the plant manager may want to obtain metrics on the efficiency or other KPIs of this plant. Today, with the explosion of IoT, or I really say IIoT, or the industrial Internet of Things, big data, the data from the shop floor is needed throughout the enterprise, allowing business to make informed decisions to ultimately remain competitive. Interesting to me as the product manager in the oil and gas industry is that this industry is taking on the same approach as manufacturing. We can swap out that plant floor at the bottom with a gas asset, same initiatives for distributing the data from that set throughout the enterprise apply. This activity in the oil and gas space today, and automation is playing a large part in making that all possible. Okay, enough about Kepware. Thank you for letting me spend some time giving you our perspective on the importance of data collection in your industry. And I'll start talking about the subject of this webinar in the white paper that suggests a new distributed architecture for data collection and communications. I will first talk about the traditional approach to communications, which we refer to as the host-centric model, and the challenges that it presents. Then that will be followed with a discussion on this new distributed approach to communications and how it can be a vast improvement over the host-centric model. And then conclude with a summary and some time for answering any questions. By the way, please don't hesitate at the end to ask a question with the chat feature. I'm linked here in Kepware with supporters that will be answering your questions and providing immediate answers or saving them for the end. Okay. Control system are various hardware and software components and communication technologies that tie everything together. How an overall system is designed can vary greatly. As mentioned, we will focus on just two models. The first we look at is a very common model and is referred to as the host-centric model. So first, let's talk about is the host-centric model. We can host a single computer that is responsible for one or more tasks. In our scenario, or your scenario, the host may be responsible for running a SCADA system, a historian, an AMI, an event management system, perhaps measurement software, or any application critical to your operations. It may be dedicated to a single application, or it may run many of these applications concurrently. And next, to software applications to the underlying hardware components or field devices, the host will also include and run the appropriate data collectors. Many times these data collectors are known as drivers and are proprietary or embedded within each application. And they may run as a standalone communication server, acting as an abstraction layer between the application and the hardware. Many times the standalone server supports an open standard that can be used by many different applications. An example of an open standard used to bridge the gap between applications and all the diverse hardware is in the automation space is OPC. A good time for another poll question. Curiosity, many of you on this call now are familiar with OPC. I'll just 2 seconds to answer that poll. Okay, and moving on. Applications connect the underlying field devices through the data collection layer. This allows applications to monitor and control the field devices needed to fulfill their responsibilities within the control system. the type of field devices vary based on the overall application. They include PLCs, or point logic controllers, RTUs, remote terminal units, computers, pumps, really any component that is required to be monitored or controlled within the system. This is not limited to field devices. It may very well range or include software applications such as databases, business applications, or other OPC servers. I like to collectively call these data sources. The communications bridge between the collector and the data sources could be hardwired or utilize a wireless technology. The collector will utilize this communication medium to bridge the gap between the hosted applications and field devices. The communications medium comes in various forms and are selected based on the environment, the cost, or simply requirements of the data sources themselves. Include wired technologies such as Ethernet, serial, or dial-up modem utilizing a telephone line. It includes wireless technologies such as cellular, radios, or satellite. But in all cases, these technologies provide a conduit for exchange information between the parties. This medium is not enough. Each party needs to be able to speak the same language, or in the device world, referred to as a protocol. This would be similar to a telephone conversation where each communicator needs to be speaking the same language, so English to English, as opposed to trying to carry on a conversation with, say, English to German. The protocol defines the structure and rules for sharing information. Some of these calls are open, for anyone to adopt and participate in the conversation. Other times, they are vendor-specific, in which only those with access to proprietary protocol specification can participate. In their structure, they all provide a basic mechanism for reading data, which is necessary for monitoring, or writing data, which is necessary for controlling. It's the data collector, either in the form of a driver or communication server, to now to leverage the communications medium and the protocol, to connect, read, write, and disconnect from a particular field device family. Okay, now let's talk about some of the challenges with what we're referring to as the host model. And specifically talk about the oil and gas pipeline environment, which I assume many of you are in. Things that differentiate the control system in this type of environment, with let's say an automotive plant, is that a geographically distributed system. Since the control system is not under a single roof, in order to run the operation, are scattered all over the place, from control rooms to well sites. You are probably not able to physically walk the entire system. In fact, you're probably driving and maybe even flying to some of these remote locations. The of applications, due to their remote nature, are generally loosely coupled, requiring integration over wide area communication technologies such as radios, cellular networks, and satellite. As such, we don't have the luxury of running cable that you own between these different endpoints. The different applications may use different mediums to connect to devices, but what is interesting, though, is that many of the applications involved require access to the same data from the same source. You can't often run on cable. You're probably going to have to rely on someone else's network, either telephone, cellular, satellite, something else. Or if close enough, radios could be an option as well, which are a set of challenges. General challenges with networks include bandwidth limitations, where these applications compete for bandwidth, which results in performance degradation for all. Environmental impact, where a line of sight obstructions can be an issue for technologies like radio or which can be a challenge for satellites, carrier communications. Cost is an issue. You might have to pay a fixed rate. Or worse, you might be paying a cost per byte of data transmitted through the network. Security, on all networks, there's always the chance for information to be intercepted and for malicious purposes. So security can quickly become a concern and needs to be in the forefront of our minds. All right. Let's do another poll question. To know if the companies on this call own networks or utilize some sort of public network to communicate remote operations. Or may or may not know this based on your role. So just give a few seconds to answer that question. Okay, moving these challenges we discussed prior to that poll question, let's look at how the host-centric model applies. The host-centric model. Applications be on the same computer, each own need for data collection using their own drivers or communication servers. So in this case, the applications are all competing for the system resources of that shared computer. Likely, the data collectors need to use the same communications medium. There's an RS-232 port, or attend with each other for that medium. This means that a single application may starve others from utilizing what should be a shared resource. And that graphic is depicting mobile data collectors are accessing the same field device data and bringing it up to their respective applications. Unaware of what the other applications are doing. All applications are accessing the data from the same device. So with multiple connections, unneeded demand is put on the device itself, asking it to serve multiple connections and requests at any given time, when the resources of these devices should be used for their primary role, controlling a local operation. These requests not only put unnecessary load on the devices, but also putting unnecessary demand on the network. As traffic increases, performance will decrease, as well as the chance of dropping communication requests. These will actually rise. Many applications are serial in nature, which results in one data collector sending a single request one at a time. Times that a device might be unresponsive, a data collector will often be configured to retry multiple times, keeping itself busy while also keeping other data collectors out from being able to communicate with that same device. As you can imagine, this can be very inefficient, especially in the cases where applications are requesting the same information relative same time from the same data source. This adds to the degradation of performance and system reliability. A failure can affect the entire host. As applications, there will likely be a need to scale your system. This is possible with the host-centric approach, but will come at a cost and a level of difficulty. Applications and collectors will cause more demand on the network. If you don't own the network, this will cost you from a cost per byte perspective. It will require continual tweaking and engineering to maintain the previous performance you had before the scaling. The slide on the host-centric model deals with security, topic today for sure. These device calls were specifically developed with performance and low bandwidth conditions in mind. So as such, these protocols contain just enough structure and rules to get applications and data collection job done. You can be sure that no attention was ever made to security back when these were developed, as this would significantly add to the overhead of the protocol. So communications over public domains could result in disaster. Data, such as your company's intellectual property, could be intercepted by others. malicious person could insert themselves into the communication stream, providing what appears to be good data to the applications while actually destroying the underlying system by taking control of the field devices. These are the couple examples of security concerns. Another poll question. Does anyone on this call use protocols across a network and are concerned with security? So again, those of you on the call may or may not know this. Don't hesitate to say I don't know, but if you do know that you are using device-level protocols, are you concerned about security? Aaron, fire up that poll question. Give you some time. Enough being up on the host-centric approach, but there is a better way. How can we do better? Let's switch over to what we refer to as the distributed architecture for applications. We'll start by defining what it is. This approach takes all the redundant and unnecessary duplication of communications found in the host-centric model and collapses it into a centralized platform. In a way, all communications to the data sources are done from one single location. This essentially allows for the centralized platform to broker requests from the multiple applications, which may be on different multiple hosts, and analyze the communications requests to and from the data sources. The communications platform itself can be distributed to ensure that it itself is not a bottleneck in the system. This allows the user to balance the load in order to achieve the performance, reliability, and scalability requirements of the operation. We will begin and take a closer look. The architecture provides a single interface data collection to field devices. So rather than each host installing its own instance of a data collector, the applications would connect to a shared and distributed data collector. The field devices could come from different vendors. So the centralized data collector would have to support multiple protocols simultaneously. In addition, the interface to the applications should be a standard protocol and allow for a security model that can be tailored to your operation. By communications in this matter, we can detect requests for the same data and analyze communications to the data source down to a single request, or at least to a minimal set of requests. In addition, it can detect requests for different data, but from the same device, and therefore intelligently acquire all the data in the fewest requests possible. This architecture allows for all communications to go through one single location. Exclusive access can be made to the communications layer, which can remove the constant connect and disconnect traffic. In wired communication mediums, the field devices will already exist, and data can be retrieved immediately when needed. This is extremely beneficial in that normal data requests are actually very fast, relative to connect and disconnect requests where the device has to manage connection state. This architecture favors putting the communications layer as close to the device as possible. This minimizes the chance of failure between the connection of the data collector and the data sources. It also removes the use of unsecure device protocols across the public domain. We will have additional benefits from that. So in the same example as before, that scenario where we had several applications that need data at the enterprise level, there on the top, as well as a local HMI, let's say down there at the facility level, off there to the left. The abstraction layer between the applications and the data sources down below. This simplifies configuration and maintenance of the system. Tools for setting up and troubleshooting, all located. Regardless of protocol, a single secure interface is provided to the applications, allowing for information to be transferred securely over infrastructure while setting off the local unsecured traffic to the whole private area network. This approach provides better utilization of bandwidth by reducing the amount of redundant requests and traffic over the network. This decreases costs, especially for a cost per byte arrangement. It also provides for load balancing, which is achieved by distributing communications appropriately for what makes sense geographically as well as your communication requirements. This method also makes better use of the required communications medium. This is in the complete control. It can ensure that the highest priority requests defined by the user are processed in appropriate order. With the application of wiring integration, we have also minimized the potential for failure points that are hard to identify and resolve in more complex host-centric layouts. And I can't reiterate this enough, the distributed architecture allows you to easily layer security on top of less than secure device layer protocols. Given the heightened concerns and reality around cyber attacks, any traffic that runs over the public domain must be securely transmitted. This is especially critical in your industry. A review, hopefully everyone can see what we're driving at here. If we go back and forth between a host-centric approach, which is enlarged in this slide, so you can better see with the applications each having their own data collector and hitting the devices directly and opening the wide area network, and can compare that to what we call the distributed architecture, which is blown up, with the data collector being put in direct contact with devices, is able to communicate with them directly and put the data to the applications using a standard protocol like OPC that we had mentioned earlier. I mentioned this in the previous slides, but I imagine many here on this call might be familiar with OPC UA, with the latest version of the OPC standard. UA stands for Unified Architecture, which means many things. One technology is no longer tied to Windows or DCOM. It can be implemented on any operating system. And I know some people on this call might be already thinking that you wouldn't want to have to put or deploy a Windows box out in the field. This has come up in every conversation I've had on this topic so far. So OPC UA has another benefit, and this is security. You can send an OPC UA tunnel to communicate across the network and tunnel through firewalls, and really set it up without having to do any DCOM settings. Okay, so in summary, a distributed communications architecture is a better solution for a loosely coupled system. Its configuration and maintainability by collapsing the communications to a single location. By your communications, you will achieve the best performance possible. Have a single platform responsible for handling the many client application requests and handling them into the fewest device requests. As a result, the reliability of your system improves, additional burden off the data sources and communications infrastructure. And by placing the communications platform as close to the device as possible, you're to utilize secure methodologies for exchanging information with applications over area communication networks and unsecure communications to the more local private area networks. Lastly, the technology exists today that will allow you to drop in a distributed architecture and migrate from a legacy setup to a much more optimized layout. You have different architectures concurrently, allowing for a migration path on your time frame. On cabling, engineering, and less downtime, move new architecture is cost-effective and should not be a barrier to entry. That concludes my presentation. I hope you found it helpful and it sparked some discussion. we will answer any questions that came in during the presentation, or please feel free at this time to pop us a question in your window. We will just hold here for a little bit to give anyone a chance to ask any questions or comments in general. One question that had come up when I presented this paper at a conference was, do you have any hard data that shows the better performance of this approach as opposed to the host-centric approach? And truthfully, no, we don't have any of that hard data. But hopefully, just by kind of seeing these graphics and think about it, that you're bound to have better performance. And if no one wants to answer or ask any questions at this time, you should have our contact information here at Kepware. We're always interested in speaking with you personally, so feel free to reach out to us after this call. And to wrap things up, again, thank you for your time. We have a question.
We call this distributed when data seems to funnel through the OPC server.
You did aspect, and I mean, I understand it's kind of semantics, but a question?
Yeah.
Okay.
They can hear it on the call.
Yeah, why do you call this distributed when it seems to be funneling through the OPC server? So it's kind of like semantics, but what the distributing, the word distributed is referring to here is instead of your data collection being done kind of, at the enterprise level, or wherever your corporate headquarters be. Let's say you're taking that data collector or the data collectors and you're distributing them geographically throughout your enterprise. So you're putting, several servers out in the field, closer, at the facility level or set level, where they're more directly connected to your devices. I hope that's your question. It's a good point. It's actually, one that has been asked before. All right, we're looking for a few more seconds here. Otherwise, again, thanks a lot for everyone's time and joining us today. Really appreciate the offer to present to all you. And if that's a great day.